Hello everyone, my friends, my viewers at home. Uh, it's another interesting video, and today we are going to be working on organic chemistry. And that part of organic chemistry that we are going to be working on is what we call bicyclic compound, as you can see right here on the board. Now, the naming of bicyclic compound has been a problem to many students all over all over many institutions, and today we'll be taking our time to give you the rules. First of all, we tell you the description of what we call a bicyclic compound, which is a member of a polycyclic compound. Then I will also let you know how to be able to identify a bicyclic compound, and also the rules guiding bicyclic compound, and also examples. We saw so many examples just to illustrate our point, but not to waste time. A bicyclic compound is from the word bi, means two. A bicyclic compound is a compound that consists of two compounds, see, of two rings that are joined together. Two rings, bi, two, cyclic, ring, or closed. Now, basically, we cannot talk about what we call a bicyclic compound without first talking about what we call a bridge-head carbon. Question now is, what is a bridge-head carbon? Simple. A bridge-head carbon are the common carbon, that connects two rings in a bicyclic compound. And how do we identify them? These are the what now? These what you are seeing here are what we call the bridge head. The bridge head. These two carbon here, these two carbon are the two carbon that are connecting this ring A and ring B. The same thing here. This two carbon here that you can see me darkly for you now is the bridge-head carbon. And we have said that a bridge-head carbon is a carbons that connects the two fused rings together. Now, basically, we have two types of bicyclic compounds, and they are one, what we call fused. When we say fused, when the bridge-head carbon atom are adjacent. An example of a fuse is what you are seeing here. When these two bridge-head carbon are adjacent to to one another, as you can see right here on the board. Then what we call a bridge. A bridge is when a bridge-head carbon are not adjacent. I mean, the opposite of bridge is for for fuse. You can see. You see now, this is a bridge. A bridge. These two carbon here are the bridge-head carbon. You get me now? Now, the thing is, we have rules that guides the naming of of bicyclic compound, both for BICYCLO and also for spiral compound. Now, in naming for a bicyclic compound, the rules are one. So find the highest priority functional group, which you must identify. This this functional group will be the surface. If there is none, it means it must be an alkane. And count the total number of carbons in the molecule, which gives you that is the first thing you must do. That is the first thing you must do. And that counting must begin from the bridge-head carbon. I hope you are following. Good. Now we continue. Number two rule is that identify the two rings of the bicyclic molecule. Now, the bridge-head carbons are where these rings meet, which I have explained to you that we have the one for fused and the one for for the bridge. Number three is begin numbering at one bridge-head and follow the longest path to the second bridge-head, which is another. For example, let's start. Now, if I want something of these two rings now, the first thing you do is to count the total number of the total number of carbon here, which are which are 1, 2, 3, 4, 5, 6, 7, 8, 9. How many? From here now, it is non-name. Non-name. Why we say non-name? It's because this compound there, this fish compound there, fall under the alkane family, which is determine the surface. One. Number two is that you have been able to count the total number of carbon. And number three is that, look at it. I'm having the bridge head here. And the way you do your counting, if here is ring A and ring B. Now, simple. If I'm having two persons, let's say A and B. Now I'm having, let's say there is A and there is B. Now, one small boy and one giant. Which among these big and small will you see first? Is the big one, which is the giant. So, and it is that giant you must count. So it means that I'm having here, look at it, oh, look at it. I'm having here 1, 2, 3. I'm having here 1, 2, 3, 4. Your numbering must start from the largest ring with the largest number of carbon atoms, which is from the number here. Here becomes start from here 1, 2, 3, 4, 5, 6, 7, 8, and 9. You see it now. And when you start from there, number 4 is find all unique parts between the bridge head carbon and along each part. Meaning you are just after the size. And what is the size? Meaning, look at it. I'm having here as A and B. B ring contains the largest part. Now look at it. This is the rule. The rule is in naming the bicyclic compound. The rule is bicyclo A, B, C. Then the parent name, which is the parent name. Now, what does this A? What does this B? What do they represent? Now look at it. This A is it belongs to the number of carbon in the ring with the largest number of carbon atom, excluding the bridge head. Simple. It means that you do not count the bridge head. Now you are just after the other carbons that are here outside the bridge head. While B, for the other ring, you are after the other carbon atom, excluding the bridge head. While C is the connector, the common bond or the common atom here. Now look at it here. Is there anyone here? Is there anyone here? Is there any carbon here that connect both this that connect this bridge head? No. So it means this A here is 1, 2, 3, 4. Here is 4. You move to the other one. 1, 2, 3. Here is what? 3. But see, is there any one here? No. So here becomes 0. Which is at the same time, in this case here, I will number. Now look at it, let's count. Here is 1, 2, 3. But look at it. The way the structure is. This is 1, 2, that's 1, 1, 2, 1, 2. But here is 1, 2, 3. So it means your number will start from the largest part, which is here. You start from here with 1, 2, 3, 4. Remember, there's a carbon here. 4, 5, 6, 7. And then here becomes what? Now 8. That is the carbon atom here. Now it means already now this compound here you are seeing here, right here, is an octane. This is the parent name. You have to say, is it a bicyclic compound? Yes. Why is it bicyclo? It's a bicyclo because 2 carbon atoms is what connects them together. So they become bicyclo. And when they move to the middle, that they will then move to the letters here, A, B, and C, in descending order. Now what do we go? We can't here now because the number of carbon atoms here is small. So it becomes 1, 2, 3, excluding the bridge head. 1, 2, 3. Then here is what now? 1, 2. So for here is 3. Here is what now? Just 2. Remember that there is no carbon atom here because we just like if you remove, if you can, I think this one is a skeletal form. If you can pull this one out, you find that it just is like a straight bond, or it's straight bond. Now, but Now here is 2. Now look at it now. This bridge edge here now, a carbon is connecting them, or it has a carbon which is here, which is 1. So here becomes 1. So here becomes bicyclo 321 or 10. Now, in our next video, I'm going to be telling you, or I'll be telling you how to name so many examples. The one without substituent and the one with substituent. For now, God bless you. I remember my humble self and the Bazuka prophet. And you can always drop your comment at the comment section below. I'll be very happy to entertain your questions and give you immediate response. God bless you.